Good day everyone. We have already finished 4 parts in integration. Now we are going to part 5. You have learnt 20 formulae so far in integration. Now today you are going to learn 6 more formulae and we will be doing sums based on that. Okay. So 21 integral dx by root of a squared minus x squared is equal to sin inverse x by a plus c. You remember integral dx by root of 1 minus x squared is equal to sin inverse x plus c. That you have studied as a straight reverse formula of differentiation. Here instead of 1 you have an a squared. So here you get x by a. Similarly, the next formula dx by x squared plus a squared. You have studied 1 plus x squared is tan inverse x. Here you are having instead of 1 you have an a squared. So this is 1 by a tan inverse x by a plus c. See, don't confuse here. Here there is no 1 by a because actually there is a root. Here you have a 1 by a, then tan inverse x by a plus c. You group these two formulae together and then you study. Then the next two formulae can be grouped together. Integral dx by root of x squared plus a squared is equal to log mod x plus, then whatever is here you have to write root x squared plus a squared plus c. The next one, integral dx by root x squared minus a squared log mod x plus whatever is here root of x squared minus a squared plus c. So group these two things together. See, there is a root in both. Here it is x squared plus a squared. Here it is x squared minus a squared. Okay. Come to the last two. We have to group them together. Here there is no root in the denominator. Dx by x squared minus a squared. Here you have a squared minus x squared. The first one is 1 by 2a log mod x minus a by x plus a plus c. This one is 1 by 2a log mod a plus x by a minus x plus c. Copy down these 6 formulae in your formula notebook. You should read them. You should by heart them. It should be very clear. But suppose you forget the 26 formula, nothing wrong. From this you can take one minus out and you can use that formula. Okay. So now anyway you learn the 6 formulae. So now we will see sums based on these 6 formulae. Okay. First model 1, that is it will be straight application of any one of the 6 formulae I have given you. Okay. So now see the first sum. I is equal to integral dx by root of 9 minus 16x squared. Let me write this as integral dx by root of 3 squared minus 4x the whole squared. So now this is of the format integral dx by root of a squared minus x squared. In the place of a you have 3. In the place of x you have 4x. Here remember I have told you some time before one expression, linear algebraic expression. Here what is in the bracket should be only x or multiples of x. You cannot have any x squared or x cube here. Okay, remember that. So this formula is, I will write the formula here, integral dx by root of a squared minus x squared, that is equal to sin inverse x by a plus c. So if you write the formula for each sum, then you will easily get it by heart. Okay. Now, so here I told you a is 3 and in the place of x you have 4x. So now I can write this as sin inverse. In the place of x let me write 4x by a is 3. Now you have to remember wherever you have got a coefficient for x, you have to divide it by that coefficient, then 1 plus c. I can write it properly as 1 by 4 sin inverse 4x by 3 plus 6. Do you understand? This is very easy because it is a very straight application. Just to see what is in the place of a, what is in the place of x. If there is any coefficient, divide. It will be definitely either one of the 6 formulae. Okay. Now let us move on to the second sum. Integral dx by root of 3 minus x the whole square plus 4. This is of the format integral dx by root of x squared plus a squared. In the place of x, you have 3 minus x. Okay. So, I will write I is dx by root of 3 minus x the whole square plus 2 square. So, in the place of a, you have 2 here. Now, let us write the formula integral dx by root of x squared plus a square is equal to, okay, do you remember? Log mod x plus whatever is there you have to write x squared plus a squared plus c. This is the formula. So, now let us substitute. That is equal to log mod. What is in the place of x? 3 minus x, okay, plus root of x squared plus a squared is this one or the sum. 3 minus x the whole square plus 4 plus c. Here, now you have to remember the x has a coefficient minus 1, isn't it? So, now we have to divide it by minus 1. So, that is very important. Whatever be the coefficient of x in integration, you have to divide. So, now I can write this as minus, I will bring here log mod 3 minus x. This part actually I can expand and simplify and give it as a quadratic. That will be nice. So, here if I do a minus b the whole square, I will be getting 9 plus x squared minus 6x. So, now I can write x squared. I will get minus 6x. Here one 9 and there one 4. So, I will be getting 13 plus. This will be a nice format. So, you can expand. If you don't expand, it's not a problem. But it is better you expand. So, these two sums are examples of direct application, straight application of the formulae. Now, let us move on to model 2. Okay. The second model is, first you have to substitute and then you will go to the application of the formula. Now, let us see. I is equal to integral x squared by root of x power 6 plus a power 6 dx. You know, x power 6 is x cube the whole square. A power 6 is a cube the whole square. But when I have in the bracket x cube, I cannot apply the formula root of x squared plus a squared. I told you that should be a linear algebraic function. You also have an x squared in the numerator. So, here actually I am going to substitute x cube is equal to t. Then only I will get x power 6 as some t squared, so that I can use the formula. Now, when x cube is t, whenever you substitute, you should remember the next step is differentiation. Never forget it. So, here if I differentiate, I will get 3x squared is equal to dt by dx, or x squared dx will be 1 by 3 dt, right? Bring the dx here, bring the 3 here. So, now your I will be, now you write the 1 by 3 outside. X squared dx, that will become now dt because 1 by 3 I have taken. Here I will get t square. This you can write a cube the whole square. Since a is a constant, whether you have a or a squared or a cube, that doesn't matter. Only now t is the variable of integration. So, only that should be the linear part. Okay. So, now the formula is, you know, it is integral dx by root of x squared plus a squared, that is equal to log mod x plus root of x squared plus a squared plus c. This is the formula we are going to use. Now, we have in the place of x we have t, and in the place of a we have a cube. Now, we are integrating with respect to t. So, write the 1 by 3 as it is. Okay. Then log mod, you write t, okay, plus root of t square plus a cube the whole square is nothing but a power 6 plus c. Now, you substitute x cube Wherever t is there, you put now x cube. So that you will get 1 by 3 log mod x cube plus root of x power 6 plus a power 6 plus c. Do you follow? So, this is the second model as I told you. You have to substitute and then you will go for the application of the formula. Your answer will be in terms of the new variable t or whatever variable you put. Then you have to replace it by x. The final answer should be in terms of x only. Okay? Understood? Now, let us do one more sum. See here, I is equal to integral secant squared x by root of tan squared x minus 4 dx. Here it is very easy to understand the substitution because you have a tan squared x and you have a secant squared x. You know when you differentiate tan x, you will be getting secant squared x, right? So now naturally you will put tan x is equal to t. So secant squared x dx, that will be dt, right? dt by dx, I brought the dx there. So now the I is equal to dt by root of t square minus 4, I am writing it as 2 square. So now here what formula I have to apply? It is integral dx by root of x squared minus a squared. Here it is x squared plus a squared. There it is x squared minus a squared. So it is log mod x plus root of x squared minus a squared plus c. So now let us do now log mod. I will get t plus root of t squared minus 2 squared is 4 plus c. Then I will write wherever t is there, I will write tan x. So I will get a tan x plus root. Here tan squared x minus 4 plus c. Do you follow these two sums? So this is the next model I will say, where we are first substituting and then we go for the formula. It will be any one of the 6 formulae, that is what you will get. So hope you have understood these two models clearly. In the 2 models we have done, you know, the denominator was either a straight application of the formula or after substitution it becomes a straight application. But it will not be always like that. So, your denominator may be a quadratic, okay, where you are not able to express it in the form of that formula format. So, for that, first I will teach you one concept, that is completing the square method. If you know that, you will be able to do any sum easily, okay. In the completing the square method, I am actually categorizing it into 3 types so that you can understand it easily. So first, let me tell you the type 1. That is, if your quadratic, the coefficient of x squared is plus 1. How to use completing the square method, okay. So my type 1 is the coefficient of x squared should be plus 1. That is the easiest type. That I will teach you first. So now I am given a quadratic x squared plus 6x plus 13. Here you know any general quadratic we call ax squared plus bx plus c. Now take the coefficient of x, that is 6, right? Now in the working column you divide that 6 by 2 so that you will get 3. Whatever be that number, divide by 2, okay? Then you square what you get. I get 9, right? Actually, this is based on like a plus b the whole square, a minus b the whole square, that concept, and the 2ab term. It is based on that only. So take the coefficient of x, divide by 2 and square it. Now you write the given expression as it is. You add and subtract what you get here, that is that 9, okay. Now you are having 5 terms. You underline the x squared, the x term. Now what you have added in that, the positive one, okay. Now this is equal to the square root of x squared is x. The square root of 9 is 3. This is plus, so put a plus whole square. Now you expand x plus 3 the whole square. You will be getting x squared plus 6x plus 9. Correct? Now supposing here is a minus sign. You put a minus sign. Now these two terms are left out now. That is plus 13 and minus 9. So I get a plus 4 there. So I can write plus 2 squared. So now after doing this, this is of the format x squared plus a squared. So I can use in the formula this formula type and I can integrate. So let me explain to you again. In the type 1, the coefficient of x squared will be plus 1. Okay? Write the expression as it is. Divide the coefficient of x by 2. Square it. You add and subtract. Okay? Then take the x squared term, x term and the positive thing you have added now. That will be either of the format a plus b the whole square or a minus b the whole square. The square root of x squared, the square root of 9. This is plus, so put a plus. Then you can check, no? You can use the formula and you can check. Now the two numbers 13 and minus 9. So I get 4. So I write plus 2 the whole square. Now you just understand these types. Then I will tell you how we are going to use it in the integration sums. Okay? So this is the type 1. Now let me go to type 2, where the coefficient of x squared will be a negation. Okay? That is, you consider 5 minus 4x minus x squared. Here, the x squared has a coefficient minus 1. This I call as type 2. Now, what I am going to do is, take a minus out. That is the first thing I am going to do. So now, I will write the x squared term first. This will also become plus. This will become minus 5. Okay? Do you follow? What I have done now? To make the x squared coefficient positive, I am taking a minus out and I have changed the sign of everything. Now, whatever is in the bracket is like our first model. Okay, yeah. So now, what is the coefficient of x now? 4. Divide by 2, you get 2. Square it, you will get 4. So now, you write minus x squared plus 4x minus 5 plus 4 minus 4. Okay. Now, as you have done there, take this term and the positive one. So, minus x squared, the square root is x. 4, the square root is 4. This is plus, so plus. Okay? X plus 2, the whole square. The number terms minus 4, minus 5, minus 4 is minus 9. So, I will get minus 3 square. Here, one more last step. This minus now you have to bring inside. So, now you will be getting it as 3 squared minus x plus 2 the whole square. So, here what is the difference between type 1 and type 2? First you take a minus out. Then you repeat the process as you have done in type 1. Then in the last step, bring back that minus sign inside. So, now this is of the format a square minus x square. Okay? Is it clear? So, these are two types. Now, I will tell you what is the type 3. Okay? In type 3, you will have some coefficient, some number other than plus 1 or minus 1 for the x squared. This is the third type. Actually, these are the three types. That is, if you consider any quadratic, I am actually categorizing it into three types I told you. The coefficient of x squared can be plus 1, the coefficient of x squared can be minus 1, or the coefficient of x squared can be any other number, positive or negative other than 1. Okay? So now, whatever may be the coefficient, take it outside. So, you make the coefficient of x squared plus 1. So, that becomes now x squared. Don't bother whatever fraction you get in the other terms. Only we are bothered about the x squared coefficient. So, this now will become 3x and this will become 5 by 4. Okay? Now, what is the coefficient of x within bracket now? 3. Divided by 2, you are getting 3 by 2. Square it. If you square this, what are you getting now? 9 by 4. Okay. So, once you make the coefficient of x squared plus 1, then it all belongs to type 1 only. So, take the coefficient of x, divide by 2, square it. Now, you write this 4 as it is, x squared plus 3x plus 5 by 4 plus 9 by 4 minus 9 by 4. Okay. Now, as usual, take this term, x term, and that positive square you have added. So, now you will get square root of x squared is x. Square root of this is 3 by 2 plus sign here. So, the whole square. Okay. Then, you have 5 by 4 and minus 9 by 4. So, you will get a minus 1 there. That is 5 by 4 minus 9 by 4 will be minus 4 by 4, which is equal to minus 1. You may get a fraction also, don't bother. So, you are getting a minus 1 here. So, this 4 can be, you can take it actually outside the integral also. Here you are getting it is x squared minus a square. 1 is 1 square. Okay. Now, you may get a doubt here after I teach you the 3 types. Now, what I have taken, I am getting 1 and easy things. Just for example, here after doing something, supposing I am getting some 7 by 3 like this. Instead of this 1, if I get some 7 by 3, don't bother. You can write that as root of 7 by 3 the whole square. So, in the place of a, you will have root 7 by 3. So, in all the 3 types, you just concentrate on the coefficient of x squared. The coefficient of x can be any fraction. The number term can be any fraction. So, we need not bother about all those things. So, I hope you are clear about the 6 formulae first. Straight application of the formulae, first model and second model, that is substitution. Then, now what I have taught you, the concept of completing the square method. In that, I have taught you now 3 methods. So, if you are clear about all these things, in the next video, we will be doing sums based on the 3 types of completing the square method, how to do the sums. And then I will teach you something new also. Thanks for watching the video. Share it with your friends and classmates if you like the video. Bye for now. We will meet in the next video.